Hi ladies and gentlemen, this is Mr. Green and this is another in a series of recordings for geometry. Where are we at? We're in the special issues section of geometry. We're covering some things that are just kind of outside the realm of normal geometry, okay? So don't forget, make certain you get all those quiz corrections turned in because you want to make certain your grade gets up as high as it possibly can get to, okay? And due dates. Don't let any zeros stay out there in your grade book. You want to get those turned in as quickly as you possibly can. So what are we talking about today? It says self-similar objects. Actually, the concept is fractals. Fractals are a thing of nature. If you look at this leaf, see how it's divided up into little bitty portions? It is similar to itself over and over and over again, like this square was. Okay? It's a self-similar type object. Okay? But they're called fractals. Fractals have been used in map making. Fractals have been used in a lot of different things. Art uses a lot of fractals in it. Art, one way of building a fractal, an easy way of building a fractal. I drew a rectangle here. I'm going to find the midpoint of each side of that rectangle, and I'm going to connect those midpoints with lines. See what I'm doing? All I'm doing is connecting them with lines. Then I'm going to come along here and I'm going to find the midpoint of each one of the lines that I just drew. And I'm going to connect each one of these midpoints with a line. I'm not doing a perfect job at it here. Okay? And then I'm going to find the midpoint of each side. This is the directions on the back of the shampoo bottle. Rinse, repeat. Okay? So you can see, I'm just doing the same thing over and over and over again. What am I getting? It's called a fractal. And I could keep going like this as long as I wanted to. Okay? Going to get smaller and smaller and smaller, the little squares are. Okay? Here's another way of doing it. What if I took a rectangle like this? I divided it up into 9 little things, and I color the middle third of each side. Okay? I'm coloring the middle 1/3 of each side. 1/3 of each side. I'm going to make myself a pretty little fractal here. Fractal. Now I'm going to take each of these uncolored squares and I'm going to divide them up, and I'm going to color the middle third of each side of these uncolored squares. Okay? You get the idea what I'm doing? Okay? Okay? What am I going to wind up with? Okay? It's going to be it's going to be pretty interesting. Okay? Pretty interesting. And I'm not doing a perfect job of it here, but you're getting the idea what it looks like. Okay? I'm trying to get this done quickly so we can move on. Okay? So where's another square that I could actually color now that I've done this? Well, I've got this one here that I haven't touched yet, and I've got this one in here that I haven't touched yet, and I've got this one out here that I haven't touched yet. You see where the next thirds are going to come from? Yeah, there's all sorts of different places that we can, ways that we can do this. Okay? Okay? And where would the next thirds be? Well, they'd be in here. I'd color there, 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 there. Right? Okay? And I want you to see that if I divide this, I still have another empty squares there that I could be coloring in. It can get smaller and smaller and smaller and smaller. That's what the idea of a fractal is. Here's an idea. Let's do some extra credit. Draw me a fractal like this. Okay? Make it pretty. Give me different colors. Make it accurate. Don't guess like I did here. Don't just color in and make it go from that. Actually divide them in thirds and find the exact place where it would be. Color as much of it as you can, as detailed as you can possibly get. Okay? Okay. This is called a Menger sponge. A Menger sponge is simply starting with a cube, doing a similar type of thing. This is a cube on the inside of it that's been taken out of it. Now I would also have a cube, have three cubes on the top, each top here, and three cubes on each bottom down here, and three on each sides. So essentially, I've got 27 more cubes sitting here that I could then take one cube out of each of those. And it becomes a cube filled with spots. You can see here is looking at this same face again. You would see all these missing spots in there. And then doing the same thing again and doing the same thing again. And you get this three-dimensional fractal. Okay? So I appreciate you making certain you telling me that you're in geometry when you send me in information. I look forward to seeing you either in Class Connect or in tutoring if you have any problems. And I will talk to you next time.